Let's check our understanding of decimal division. Here we see 5 and 814 thousandths divided by 57, just as a whole number. Remember, guys, when I record this for long division, it's almost like these numbers do a crisscross. These numbers do a crisscross because this is 5 and 814 thousandths. This is what is being divided. This is the whole that's being broken up into equal groups or equal portions. This is the number of groups that's going to be divided into. Or sometimes we see this being the portion size. Again, guys, it's almost like these two values do a crisscross. Now, once I have my problem set up for long division, it's very important that I ask myself, is the divisor a whole number? If it's not a whole number, I move the decimal that many times to the right to make it a whole number. But whatever I do to the divisor, I would also do to the dividend before I bring it straight up into my answer. Now here, 57 is already a whole number. Because the decimal already sits at the end, I don't need to move my decimal to get it to the end, which means I don't need to mirror that same movement in the dividend. So instead, if this is a whole number, then in your dividend, you just rocket that decimal straight up into your quotient. Again, I may not even know the numbers that will be in my quotient, but I already know where that decimal place value is going to sit. Okay, boys and girls, do remember what we've practiced in class. However many digits long your dividend is, you must have a number recorded above that in your quotient. Very important. Zeros, especially in decimals, oftentimes are not optional. They're mandatory. They hold place value position. So we just want to get in the habit, since there's 4 digits in my dividend here, my quotient must have at least those 4 digits. So make sure you do record something above each of those digits in your quotient. Okay, now that we've already taken care of our decimal place value, I can ignore my decimal. Okay, I'm looking at 57 and I'm asking myself how many times that's going to go into 5,814. Okay, or excuse me, 5 and 814 thousandths. But it's almost like I can just ignore this decimal place as I divide, multiply, subtract, and bring down. Okay, just like we've practiced in class. We're going to go one digit at a time. And it's almost like we have a shield chunking this dividend, thinking about it just one digit at a time. Can 57 go in to 5? Can I get a group of 57 from 5? No. So instead of skipping it, I am going to record a 0 in my quotient. Then I'll move that shield over, and now I'm looking at 58. Again, I can ignore this decimal place. I've already taken care of that in my quotient. Can 57 go into 58? Can I get a group of 57 from 58? Yes, I can get one group of 57 from 58. That's my divide. Now I multiply. 1 times 57 gives me 57. That's my multiply. Now I will subtract. 58 minus 57 gives me 1. And my next step is that bring down. So I'll bring down the next value. Can 57 go into 11? Can I get a group of 57 from 11? No. Remember, do not just skip this. Instead, record a 0. That 0 is so important because it's holding that hundredths place. We must have a value in the hundredths place, and the value that needs to be there is 0. Okay? Now, again, I put a 0 here. So I'm going to continue this. 0 times 57 is 0. Now I'll subtract. 11 minus 0 gives me 11. And now I'll bring down my 4 to give me 114. Okay, that was my subtract and my bring down. Again, since I brought down, this process starts again. Can 57 go into 111? Yes, it can. Now, again, this is not a basic fact that you memorized. So you might have to do a little guess and check. Well, it seems to me that it could go in more than one time. I may not be sure if it could go in 3 or 2, but I'm going to go ahead and start with a guess of 2. The way that I'll figure that out is coming over to the side and doing a little scrap work. You could say 57 times 2. You could do 57 plus 57. Again, this is going to give me the same answer because it's 2 groups of 57. 7 plus 7 is 14. Carry my 1. 1 plus 5 gives me 11, which of course is the same thing that I would get if I did stack and solve. Well, that works out well because look, that's exactly what I have to work with. So 57 can go into 114 2 times. I worked it out with scrap paper to know that 2 times 57 gives me exactly 114. Then when I subtract, I get a difference of 0. Since there's nothing to bring down, this is the end of my problem, and I know that there's no remainder. So, boys and girls, I know that the quotient, the answer to this problem, is 0 and 102 thousandths.